Hello all, welcome to your 3.6 fourth video. 3.6 is called Markups and Markdowns, and it's specifically talking about money in the marketplace, so how much money a store buys something for, how much they sell it for to you, and then how much you buy it for if it's on sale. So we have markups and markdowns, so we'll talk about these all in respect to each other, and then we'll also introduce a couple of new terms. So we'll have cost, selling point, and sale price. So let's go ahead and get started. All right, so the first thing I want to do, we're going to talk about markups or markdowns. So this is just a brief reminder of what we talked about last time. Markups and markdowns, or amount of change, is final minus initial. Okay, so for markups, it's going to be your selling price minus your cost. So if a store buys a shirt at $5, that's the cost for the store, not the cost to you as the consumer, but the cost to the store. So is your initial, they initially bought it for the cost, let's say it's $5, and the selling price is what they're selling it to you at. So selling price is what you take home, the amount you buy for it, and cost is the amount the store pays for it, okay? For markdown, it's the same idea. It's the absolute value of final minus initial, but for markdowns, the store already has the merchandise. They already have the shirt or the shoes or whatever, and it's already at the selling price, but now they're going to take out the markdown. They're going to subtract that out to get you the sales price. So mark down, the amount that they take away or reduce from the selling price, the amount of money that you pay, will give you your sales price. Okay, so selling price minus your sales price gives you your markdown. And then conversely, selling price minus markdown gives you your sale price. Okay, so all of this is up here. You guys seem pretty confident with it in class. I'm just going to try and equate it one more time. Change is final minus initial. Okay? So I think that's something that's really, if you understand that, will help you significantly. Okay? So here we just have a picture. Let's say you have a $5 item, and then you go to $6. So $5 is the cost, $6 the selling price, and then the store can't sell it, whatever. They reduce the price to $5.50. Now that $5.50 is your sales price, okay? So 5 is your cost, 6 is your selling price, $5.50 is your sales price, okay? For a store to make any money on any deal, the selling price or the sales price need to be bigger than the cost. Otherwise, they're selling an item for less money than they bought it for, and they don't make any money. They lose money in that case, okay? When a store breaks even, that means they made no money, but they also didn't lose any money. So that means they sold you an item at cost. So if they paid $5, they sold it to you for $5. They didn't make or lose money. Okay? So to get from your cost to your selling price, you add in the markup. To go from selling price to sales price, you subtract out your markdown, okay? It might be a good idea to copy down this this figure somewhere into your notebook. We're going to be referencing a lot here. Okay, so percent of change is change over original. Okay, we talked about this in 3.5. You guys seemed really good with it. So percent markup, we're going to use the information we have from the previous page. Okay, all of this. Markup is selling price minus cost. So percent markup, we're going to find whatever that markup number is, that selling price minus cost, and we're going to divide it by the cost, or the original amount, okay? For percent marked down, we're going to use all that information from the previous page. Marked down is selling price minus sales price, okay? So we'll get some number marked down, some dollar amount, and we're going to put it over the selling price. And the reason it's over selling price and not over cost is because when you're looking at marked down, it's already at an amount. The store is saying, I'm going to sell this item for $10. And then it goes on sale. So the marked down is from whatever the price the store is selling it to you for, and then it goes down to your sales price. So your original, in that scenario, your original amount, your starting point, is whatever the store is selling it to you for. You get the selling price. So the original, the starting point, is selling price, and that's why it's selling price and not cost. Okay? So also might be a good idea to write these down somewhere. We're going to be using them pretty heavily right now. Okay? So once again, that 5 to 6 to 550. 5 would be our cost. 6 is our selling price. So you go from cost to selling price by adding the markup into it. So cost plus markup is selling price. And then once you're at your selling price, you can go from selling price to sales price by subtracting out your markdown. Okay? So percent change is change over original. And given this scenario, there's 3 different things where you can be given something and you need to find the other 2. So there's only 3 variables here: percent change, change, and original. You have to be given 2 out of the 3 in order to solve a problem, otherwise you can't do it. So the first scenario is to solve for a missing percent change. The next one is solving for a missing change, so this would be like a missing markup or markdown. And then the last one is missing original. You guys are superstars at the missing percent change, so I'll give you a problem. Some percent, what's the percent change? If the change is 3.1 and the original is 6.6, well, 3.1 divided by 6.6 is 4.469, which is 46.9% change, all right? So you percent increase or percent decrease, because both of those are under the umbrella of percent change. All right, missing change, so missing the numerator. Let's do a practice example. So let's say I told you 3% is your percent change. I want you to tell me what the actual value of the change, did it increase by 3 or 20 or whatever, if the original is 500. So I put C in yellow so we can keep track of it a little bit easier. And I'm just going to convert 3% to 0.03. So 0.03 is equal to C over 500. So I'm going to rewrite this to help you visualize it. C over 500 is the same thing as C divided by 500. So all I did was I changed it from a fraction to a horizontal division problem. Okay, so now that I have C divided by 500, how do you undo division by 500? Because I want to get C by itself. Well, if you divide by 500, the inverse of that would be multiplying by 500. So you multiply both sides by 500. The divide by 500 and multiply by 500 cancel each other out. And you're left with C equals 0.03 times 500, which is 15. So the change is 15. So given an original with 500, a percent change of 3%, and a change of 15, the change has to be 15, okay? And we can go ahead and check our answer by plugging it back in, and we could say 0.03 equals, now we take the 15 we just solved for, plug it in for C over 500, so 15 over 500. 15 divided by 500 is 0.03, so 0.03 from the 3% is equal to 0.03 from 15 over 500. They're equal to each other, so it's true. Check mark, we've checked our work. Okay, missing the original is the one that is going to give you guys the most problems. I know this already. So, give an example. So let's say there's a 5% change. The amount of change, either markup or markdown, is 12. What's the original? Okay, so I put in a red R. I didn't pick R for any specific reason other than an O for original would look like a 0, and I didn't want to confuse you. So we're just going to use R for this example. So I'm going to change that 5% to 0.05. So I have 0.05 equals 12 over R. So my change is 12, my R is my original, and I want to get R by itself. So now we have 2 options. We can use the Danny method. So Danny's method is to take the numerator and divide it by the other side of the equation. So the 12 is my numerator, I'm dividing it by the other side, so 12 divided by 0.05, so R is 240, okay? If your brain doesn't see that relationship and you don't know how to get there, you also have the option of doing proportions. So if I can rewrite 0.05 as 0.05 over 1, so 0.05 over 1 is equal to 12 over R. So all I did was I put 0.05 over 1, and now I can cross multiply, so 0.05 times R, and 1 times 12. So I have 0.05 times R on one side and 12 times 1 on the other, and they're equal to each other. And now we can solve for R. So let's first simplify the 12 times 1. So 0.05 times R equals 12. And now let's get R by itself. So just like how we did it for the missing change in the middle, if you have multiply by 0.05, you can divide by the same amount. Divide both sides by 0.05. 0.05s cancel out. R is equal to 240. Notice you get the same answer no matter how you got there. Okay, so if you like Danny's method, use Danny's method. If you like proportions, I like proportions, do that one. Okay? So now let's look at 4 problems from your homework. The first 3 will be pretty quick. The last one's a little bit more involved. So, a computer store bought a program at a cost of $20 and sold it at a selling price of $28. Find the percent markup. Okay, so I'm going to highlight some important information. We have a cost of 20, selling price of 28. Find the percent markup. So percent markup I know is markup over cost or change over cost. So the change is the absolute value between the start and the end. So it started at 20 and ended at 28, right? Cost was 20, selling price was 28. So 28 minus 20, we're going to take the absolute value of that. And then the cost, our original starting point, is $20, okay? So the absolute value of the difference between the selling price and the cost over the cost. So the 28 minus 20 is 8, so absolute value of 8 over 20. The absolute value of 8 is 8, because 8 is 8 spots away from 0 on a number line. So 8 over 20, which gives me 0.04, and move the decimal point 2 places to the right, 40%. All right, let's look at the next problem. During a sale, a dress is marked down from a selling price of $90 to a sales price of $81. What's the percent markdown? Okay, highlighted information, selling price 90, sales price 81. Percent markdown is what we're looking for. So percent markdown is markdown over selling price. So the markdown amount is going to be the difference between the selling price and the sales price. So the absolute value between the end point, 81, the sales price, minus initial, the starting point, the selling price of $90, so 81 minus 90, over the selling price, the original point. So it started off at 90 and then it dropped to 81. So the starting point, the original amount, is 90. So we're going to get the absolute value of -9, because 81 minus 91 is -9, over 90. The absolute value of -9 is 9, because -9 is 9 spots away from 0 on the number line, and 90 is just 90. So 9 over 90 gives me 0.1. 0.1, move the decimal point 2 places to the right, 10%. All right? A $290 suit is marked down by 30%. Find the sales price. So this one's a little bit different. We are given a starting point and a selling and the percent marked down. Okay? So a $290 suit marked down by 30%. Find the sales price. So 30% is the marked down, and we know that marked down over original, the markdown amount over the original. Okay, so we're looking for that M value. So how do you get M by itself? Well, first, let's label some things. $290 is our selling price, and we're trying to find the sales price. And we can find sales price by doing selling price minus markdown. So if you go back a couple of minutes, back to that drawing I did with the 5, 6, 550, sales price is selling price minus markdown. So it's at a selling price, and then you subtract the markdown, and now it's at your sales price. Okay, so we're trying to find sales price. So we need to know some things in order to get there. We need to know the selling price and the markdown. So that's why we have the 30% equals markdown over 290. We need to find markdown. We already know selling price is the 290. We need both of those pieces of information to find the sale price. Okay, so let's solve for M. So 30% goes to 0.3, and then we have M over 290. So how do you get M by itself? You multiply both sides by 290. Those guys cancel each other out, and we have M is equal to 290 times 0.0 times 0.3, which is 87. So markdown amount, not percentage, markdown amount is 87. So sales price is equal to the selling price, which we know from the problem is $290, minus our markdown, which is $87. So 290 minus 87, sales price is 203. Okay, so the sale price on this $290 suit with a markdown of 30% is $203. Okay, the last one, this one has a couple of moving parts, so just follow me along on this. The selling price of an item is $650. It's marked down by 10%, but the sales price is still marked up from the cost of $450. Find the markup from cost to sales price. So I'm going to pause here and I'm going to reintroduce, so let's highlight. Now let's go back to that drawing, the 5, 6, 550. You start off with the cost. This is what a company pays for an item to get it into their store. Okay, so cost. And then you add in the markup to get your selling price. Now once you're at your selling price, you pull out your markdown to get your sales price. Okay, so we've already seen this now twice. All right, so you're subtracting out markdown, selling price minus markdown is sales price. Cost plus markup is selling price. Okay, so we're going to need this information because it's asking us for a lot here. So let's label what we know. The selling price is $6.50, highlighted in yellow. It's marked down by 11%. So not 11, 10%. Marked down is 10%. Okay. We're trying to find the sales price. And we need to know the sales price because the question that's being asked, find the markup from cost to sales price. So I'm going to highlight that in red. This is really the important part. Find the markup from cost to sales price. So I need to know the cost and the sales price. So I know cost is $450 because it told us that. Cost of $450, highlighted in yellow. So we gotta fill in the missing pieces. So we need to find markup. We have the markdown. We'll need all that information to find sales price. Okay. So in order to solve this problem, we need to find the sales price, and then we need to find the percent markup between the cost and the sales price. Okay. So highlight important information again. To find sales price, selling price minus markdown is sales price. Okay. We just looked at that right here. Selling price minus markdown is sale price. Selling price minus markdown is sales price. So we're going to plug in what we know. 650 is my selling price. 10% is the markdown. Sales price is what we're looking for. So what's 10% of 650? Well, I'm going to pull out 10% of our $650. Well, 10% of 650 means 10% times 650, so 650 times 0.1, which is $65. So 650 minus that $65 markdown gives me a sales price of $585. Okay, so now that we know we have a sales price of $585, we need to find the percent markup. So here, we're looking specifically between cost and sales price. All right, so this is that red part right here. We're looking from cost to sales price. So it has a cost the company $450 to buy it, and now they're selling it to you at a sales price of $585. So we're going to do percent markup, same equation we did, percent of change is equal to change over original. So percent markup, the percent change is equal to change. So how do you go from 450 to 585? Well, it's going to be our change, and our original is our cost. Okay, so we're going to plug in what we know. So you go from 450 to 585 is an increase of $135. So I changed by $135. My original, my cost, was $450. So 135 over 450 gives me 0.3, which is 30%. So you had a store that bought an item at $450. They marked it up to $650. Then they marked it down by 10% to give us a sales price of $585. So from the cost of $450 all the way through that whole process of marking it up and then marking it down for sales price to get to $585, they are making a 30% profit. Okay? This, if you can understand this last problem, this is the embodiment of 3-6, okay? We're going to spend Monday, possibly also Wednesday, looking at this more in depth, but this will be our last unit in topic 3. Let me know if you have questions, and we can go over it more in depth, okay? Thank you.